We are at the lead code 200. This is the problem, and this code in here is taken from Nick White video in this one. Check that on how to generate the code. Right now I just want to debug, and in this debug we'll see what's happening under the hood. One thing is like I change it from 1 into X and from O0 into O, which means I change also the code in here from 1 into X, and also it's not E0 but it's O, and this one is O, and instead of E0 it becomes is O. Why? There are so many 1 in here, and then there are indexes of the column and row of 1, and also the value that we have in here is also 1 and 0. It's so confusing. I don't want that. I prefer to change it so it's easier to differentiate between which are which. So let's debug it. Set breakpoint in here, and we have a helper method of call BFS. We set that breakpoint in here and run the debug. The debug in here, the first information that we enter is that 4 rows, because we have 4 curly bracket in here, and each of the curly bracket consists of the 5 element. So grid.length is 4, 1, 2, 3, 4, and each of them has 5 element. If we move forward, so we are looping through the row, the I, and then we are looping through the column, and we know the column length is 5, which is grid I, whatever it is, and dot length is 5. Okay, so iteration will start at the 0, 0, because it starts at 0, and it's also start at 0 with the boundaries in here. At the 0, 0, we are going to check whether this particular coordinate equal to x or not. If this is yes, in our case is yes, we add count plus 1, which means that that is our island, and we call the helper method recursively with the grid that we have, and with the coordinate of I and j, where I is 0 and j is also 0. And then we will create a variable that check the boundaries. The first boundaries is this outside of the row boundaries. Is I less than 0, so I of 0 is here, less than 0, which means that negative 1 in here if we talk about the integer. And that's outside of the board. We don't want that. And this boundaries in here is I greater than equal grid.length. Grid.length is 4, so when our coordinate is reaches 4, meanwhile the index is only 3, we will check that in here, and it's outside of the board. And that's also happened with the j less than 0, this will be in here, negative 1, that's outside of the board, and j greater than equal to length. Our length is 5, so if we have an index 5, index 0, 1, 2, 3, 4, and 5 will be in here. That's outside of the board, we don't want to deal with that. And the last thing is that make sure is not an O, because if it's an O, then like we should not be in this helper method. Okay, right now we are at the coordinate of 0, 0, and that's an x. Cool. Check whether this is an O or not. To make it, that's a bit confusing, to make it a bit simple. This is from previously, don't look at that first. Let's delete this, and let's delete this. Okay, we are at the O, O. X not equal to O, the value is true, and then we will run this statement in here, this line. So we will convert the one in here from X into an O. Let's see that. Boom, it converted from X into an O, and then we will call the BFS in the same grid, but the coordinate is I plus 1, j. I plus 1 is in here, so at the coordinate of 1, 0. If we hit that, we are at the coordinate of 1, 0. So as in here, we execute this line, and from this line we will be 1, 0. And what is the value in here? The value at the 1, 0, I is 1, j is 0, is an x. So we are going to check whether x is not equal to O, and that is true. So when it's true, we will execute this, and we will execute this also. Later on we will execute all of them, because if this is true, we execute 4 of this line of code recursively. Notice that you were here on the first recursive or 0 recursive, and then you get inside here one, oh, that's undo. Yeah, here into this recursive, and from here we are going to another recursive, and from that I will copy it in here and do it here, and we will go into from 1,0 into 2,0. Let's check it into the code. Right now we are at 1,0, the value is x, and check the boundaries. The boundaries is not violated. Let's do that first right now. So I is not less than 0, I is 1, cool. I is not greater than equal to grid.length. I is 1, which is like not greater than equal to 4. J is not less than 0, J is 0, so it's equal, it's not less than, so that's also false. And J is not greater than grid.length. J is 0 is still inside the grid.length, and grid I comma j, that's an x, which is not an O. So we are not violating any boundaries in here, so we can move on to the next code. Right now, if not is O true, so here are we in the we are still at the 1 0 right now. So here x is not equal to O, that is true, and we execute that line statement. I just want to show you how. Okay, and we will convert this one from x into an O again. Boom, we convert that again. Then we will call the BFS another method, so we are going to the second recursive. And you can see in here, this is like the first and the second, we are going to the third recursive because of this line. And if we click enter, we are at the 2 0 at the third recursive in here. So let's mark that here. This is third recursive. Okay, what's the value at the 2, 0? The value is an O. O is not equal O, that is false. When that is false, we are not going to execute any of this. And we return back to this state, the line, the code previously at the coordinate 1, 0. Let's check that in the code in here. So we are at 2, 0, and this is false. When it's false, we are not going to run any of the code in here. We went back to 1, 0. So that's going to happen. At the 1, 0, we are done with our first statement in here, and we are going to the second statement. We are going to check at the 1, I is 1, minus 1, 0, 0. So if we go to this, so we are done with the first one in here, and we are going to execute the second line of code. And this execution will go here, and we are going to 0, 0. And notice that this 0, 0 is different from this 0, 0, even though we are at the same coordinate, because this 0, 0 happened on the second recursive. This is first recursive. So this 0, 0 happened at the second recursive, meanwhile this one happened at the first. So it's different on the layer of recursion. So at this 0, 0, we also, nope, this one I want to copy this and put it here, and we are going to check what happened at this 0, 0. It's an O, so it's not an X. So we are at the 0, 0. Not is O is false. So O not equal O is false. So we are not going to execute it. We are going back to this one, and we are going to execute the third statement in here. So at the 0, 0 is false. We're going back at 1, 0, and right now we are going to execute at the call BFS helper method of the I, j plus 1. J plus 1 is 1, 1. So we are going to undo. We are going to execute at the 1, 1. And let's copy this. I want you at 1, 1 in here. At 1, 1. The value is an X. Okay. So at 1, 1, can we zoom in? So X is not equal to O, that is true. We're going to execute this and this line, dot, dot, dot. Dot, dot, dot means it's in progress. So check the boundaries, and if it is not O, so this is a true statement, we will convert at 1, 1, which is this one, from X into an O. Yeah, from X into an O, and we will go into the call BFS of grid of I plus 1, j. So we will go into 2, 1. Voila, 2, 1. Back to the note in here. We are going to the 2, 1. What's the value at 2, 1? That's an O in here, or also you can do that in here. That's an O. So O, so O is not equal an O, that is false. When false, we are not going to do anything, and we return back here. So since it's false, we are back to 1, 1. At the 1, 1, we are also going to check for the second statement in here, where I minus 1, j. I minus 1 will be 0, so 0, 1. So 0, 1, and that value is X. Okay, so this is done, and then from here we go to 0, 1, where is X not equal to 0, and that's true. When it's true, we will execute all of them in this code. And that is true. So we will back to the code. Since this is X, we will convert that from 0, 1, which is the 1 in here. We convert that from X into O. Boom. Convert that into O. Nice. So we also go a deep layer. So right now we are at the 4th recursive. We are going to the 5th recursive at the coordinate of 1, 1, because this statement is true. See, we are at the 5th recursive at 1, 1. So since this is true, we run this, and we're going to this 1, 1. What's the value do we have at 1, 1? Is an O. So O got equal to O, and that is false. So we are not going to execute that. We are going back to the 4th recursion. I don't know English for that. So we're going back here, and we are done with this one. So we are going to also check for I minus 1, j, and that is, we start from the 0, 1. So we are going to check for negative 1, 1, and that's coming from the statement in here. So negative 1, 1. Let's see at the code. Negative 1, 1. Notice in here, invalid array index of negative 1. It violates the statement in here. If I less than 0, then we will not execute the rest. Why? Because it's outside of the boundaries. So we get out of the statement of this recursion. and we are back to the 0, 1. So this is I less than 0, and that's true. So we will not execute it. We are going back to this one, and we are going to execute the third statement, which is from 0, 1, I, j plus 1, so 0, 2. Let's see that in here. 0, 2, the value is O. So when the value is O less than equal to O, and that is false, we are not going to execute anything. We are going back here. And when going back here, we are going to the last statement, which is from the 0, 1, I, j minus 1. So we are going to back to 0, 0. Notice in here that this 0, 0 can also happen at the fourth recursion, which is already happened at the third one, which is already also happened at the first recursion. So we are going deep in here. But right now, the value of the 0, 0 is also an O, because we already convert that x into O. So yep, the value in here is O. And we also doing the same thing. So O not equal to O, that false, and we are not doing anything. So we are done in here. We are going back to the third recursion in here. Previously we are at the third recursion. So this is third recursion at the second statement in here. So next we are going to the third statement. Let's check the code first to make sure we are on check for that. Yeah, so we are going back to the 0, 1. That 0, 1, we are going to check for the 0, 0, because we are on the fourth line in here. At 0, 0, the value is an O. So we right now the code and the node we are in here, it's false, and then we back into 1, 1. We are done in here, and we are back to 1, 1. At the 1, 1, we are at the third statement. So from this 1, 1, we are going to check for the 1, 2. This is, we are going to check, let's make it down here, all the way down, for 1, 2. What do we have at the 1, 2? 1, 2, we have an O. So O is not equal to O, that is false, and we are not doing anything. We are back here. And then we will run this last statement. And what will be that? And last statement, we are at 1, 1, so we will check for the 1, 0. 1, 0. And what is the value at the 1, 0? That's also no. So O is not equal an O, and that is false. We are back to the statement that we have in here. So we are done with the third recursion that we have right now. So we will back to 1, 1. Let's do it step by step. Yeah, we are going back to negative 1. I skip it. So that the third recursion, yeah, so we are done with this 1, 1, which is from the third one here, and right now we are here at the I, j minus 1, so j is 0, 0, 0 minus 1 is 1, minus 1, so this will be 1, minus 1, and that is outside of the boundaries. So I less than 0, and that is false. We are not doing it, and we also done in here. When we are done in here, we will go back to this one. So from this one, we are at the 0, 0 to 0, 1, 0 previously, and right now we are going to go for the second statement, which is 0, -1. Back to 0, 0, and we are on the second statement in here, and not 0, -1, -1, 0. So easy to get confused. I don't want to make you confused. So, and I is 0, j is 0, so I is -1, 0 on the second statement. Let's check it. Yeah, -1, 0, it's outside of the boundaries. We are not going to execute anything at all. And right now we're on the third line in here, where it will be 0, 1. Back to 0, 0 on the third line in here, and we are going to the 0, 1. The value is also an O in here, so O is not equal to O. That is false. We are not going to execute anything, and we are going to go to the fourth statement in here, which is 0, -1. That will be outside of the boundaries, and we are not going to execute anything. Let's see what happening here. Back to 0, 0, this one, and right now we are at the 0, 1, 0, -1, 0, -1 is outside of the boundaries. We are not doing anything. So we are done with the helper method for the 0, 0. All of the axis and surrounding neighborhood for the below, above, right, and left already convert into an x, so we don't have x anymore. And we just keep looping until we find another x. Right now we are at the 0, 0, so we are going to move to 0, 1. Is there an x? No. 0, 2, an x? No. 3, and we don't find anything. As happened at the I equal to 1 in here, there will be no x, so we just keep moving forward. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, nothing. Then we will go into the I equal to 2. So 2, 0, not an x, 2, 1, not an x, 2, 2, that's an x. When it's an x, we add the count right now, so count is equal to 2. Because we already have our second island, we found it in here, and we will call the BFS helper method. This BFS helper method, check the boundaries. This is still in the boundaries. Then we will convert this x into an O. That's an O, and we will check to the I plus 1. From 2, 2, we will check for the 3, 2, which is like down here. And down here, that's an O. I'm not going to draw this. You can check it by yourself. So that's 3, 2, that's an O. We are not doing anything. We will get out of the helper method second recursively, back to the first. And then we are going to check for the second statement in here, where it's 1, 2, 1, 2 in here. That's 1, 2, that's also an O. 1, 2 is also an O. We are not going to execute anything. Back to the third statement in here, we are going to check for the 2, 3. Yeah. So in here, 2, 3 in here, that's also an O. 2, 3, that's also an O. And then we're also going to check for the 2, 1. 2, 1 in here, that's also an O. Makes sense, because that island is only by itself and there is no neighbor. So we were at the 2, 2, we done with this neighbor. We're moving on to 2, 3, 2, 4. We don't have any island at 2, 4 in here. When we'll go to the index 3 row, 3, 0, nope. 3, 1, nope. 3, 2, nope. 3, 3, yes. We have an X for the coordinate of 3, 3. And I will draw it in here because we have the neighbor. Let's start fresh. Oh, we already have that in here. Let's start fresh. Right now we are at the 3, 3, where x is not equal to O, and that is true. And when that is true, we execute this and we execute the first one in here. And let's do it quickly. So we will check for 3, for 4. I can undo, delete this. 4, 3. And then we will check for 2, 3. We will check for 3, 4. We will check for 3, 2. So that is when I plus 1, when I is 3, I minus 1 in here, when I is 3, j plus 1, when j is 3, and j minus 1 when j is 3. Okay, cool. So, back to the code here. Yeah, we go inside the helper method, and we will change this into an O. That's changed into an O. From 3, 3, we will check for 4, 3. That's outside of the boundaries. That outside of the boundaries, I greater than equal to length. So we will not execute anything. Go back here and go to the second statement in here. The second statement, 2, 3. 2, 3, where is that? 2, 4, 3, 2, 3. That's the one that's above it in here, and that's an O. We will not execute anything. So O is not equal to O is false, so we will not execute anything. Cool. And then we go to 3, 4. Here 3, 4 is an X, so it is an X. So X not equal to O, and that is true. And we will go to another recursion. Hey! Hi! Another recursion in here, and I think I'm done with you. So let me delete this. So that's 3, 4. We will change this one from X into an O. The last one, boom, that's an O. And we are going to do series of the check in here, in which there is no more X, but we still, for practice, check for the coordinate. Right now we are at the 3, 4, so we will check for the 4, 4, and then for the second one is 2, 4. So this is 3, 4, and then we'll check for the 3, 5 and 3, 3. This is 4, 4 is an outside of the boundaries. 4, 4 is outside of the boundaries because our I is only up until 3. So this is I greater than equal to length. We are not doing anything. 2, 4. Let's do it step by step. That's outside of the boundaries. 2, 4 is an O. So O is not equal to O, so we are not doing anything. Then go 3, 5 is outside of the boundaries. J equal length, equal to length, which is like outside of the boundaries. We are not doing anything. And then 3, 3 is just an O. And then like not doing anything. So we are done executing all of the recursive line in here. Wait, we have 4, 5. What is that? No, it's 3, 2. Yeah, we get out of this loop, and we are at the 3,3, and the last one is only 3,4. At the 3,4 we are not doing anything because it's an O, and we have count equal to 3. That will be number of our island, and we are done with this code. Expected is 3, it is equal, the result is equal as expected, so we know that our code works well.